Hi, and welcome to the part 2 of this week's lesson, which is about system modeling using block diagrams. In the previous video, we have learned different roles for simplified block diagrams to eventually obtain a final block diagram, which has only one block containing the transfer functions to present the relationship between the output and the input. In this video, I'm going to use two examples to show the applications of different roles for simplified block diagrams. And based on that, we can simplify different block diagrams, obviously. Here are two examples, 1 and 2, showing different block diagrams but have many blocks within them. So the task is to obtain the transfer function, which means one single block will be contained in each block diagram, and the transfer function will be in that block. So here is the example 8.1, which is the top one, and that is the block diagrams. You will find there are 3 blocks plus a summing element at the very left hand side. So immediately when we look at this diagram, we can apply the combining blocks in series rule, which are these two here, which connect in series, k and 1 over 1 plus 0.1s here. So by simply applying the rule 1, which is the series one, G1, G2 will be equaling to G1 times G2. So in this case, G1 is k, and G2 is 1 over 1 plus 0.1s. So these two here. So by simply times G2 by G1, we will have k over 1 plus 0.1s, which is the one showing here. Then we also find for these diagrams, there was a feedback loop here, and on the feedback, there's just a constant 0.5. So if we're comparing this diagram to the row 3 diagram, which is this one here, in this case, what we know is that G is equaling to k over 1 plus 0.1s here. So they are in the same position, okay? And we have the h here, which is equaling to 0.5. Again, previously, we have already developed the transfer function for this loop, which is g over 1 plus gh. So we can simply substitute the values into this equation. In this case, the value for g, again, is k over 1 plus 0.1s, and the h is 0.5. So this one will be equaling to this term here, by simply just derive the term 1 plus 0.1s at both the top and the bottom, then we will eventually get the transfer function of the g over 1 plus gh, which is k over 1 plus 0.1s plus 0.5ks. So that is the final the final block diagram, which has the transfer function in one block, showing here. Now it is quite obvious the relationship between the Cs over Rs is equaling to k divided by 1 plus 0.25k plus 0.1s. So this is the first order transfer function as we just learned, because the highest power of s is just 1. And now let's discuss about example 8.2. This one is slightly complex. You will find 2 feedback loop in this block diagram. But we can further simplify that by individual steps. The first steps, as we can observe, there is a feedback loop in the red part here. So what we can do is similar to the previous solution. We can apply the row 3 again. In this case, g is equaling to 1 over 10 times s squared, which is 1 here. And we have the h, which equals to kv times s. So this is kV times S. So again, just by applying the rho here, what you will get is an integrated block with the function of 1 over 10s squared plus kVs. So then, because we have this integrated block, we can have this single block here, right, to represent all these parts, the summing element plus this block and that block. So this diagram becomes quite simple. So the Kp is still Kp, but now we have this single block to represent the summing element plus the other two blocks. Now you will find the Kp is in series with the new block here. So by simply apply rho 1, in this case, G1 is Kp, G2 is 1 over 10 times S squared plus KVS. So you can put these two together to make this integrated block. And once this is done, you will find there is still a feedback left. So we still need to get rid of the feedback. Again, we need to apply rho 3 again to get rid of this feedback. In this case now, G is this term, the new block we just developed, and we have a H. Because there's nothing in the path of the feedback, so this is just simply just 1, okay? The H here will just be 1, so you will have a straight line pointed to the minus here. So the H is equaling to 1, and G is equaling to this term. Again, we apply the rho 3, we can get these equations here. And if we times 1s squared plus KVS on both the top and the bottom, which is basically the part in red, and then we can get rid of them. And that's the final expression, or the final transfer function. Then we know the output theta O against the input theta I is equaling to this term, and that is transfer function. Thank you for watching the video, and this is the end of the video. Thank you very much.